My name is Ruju Boskert, and I'm here with Dr. Michelle Staben-Walker, who is a chemical engineer working at GlaxoSmithKline in pharmaceutical development. Hi. Hi. How did you get interested in chemical engineering?
Well, back when I was in high school, I didn't really know what I wanted to do, so some of my teachers said, hey, if you're good at math and science and you really like it, you should be an engineer. So that was pretty much it. And then I started looking at colleges and ended up at NC State, and I got interested in chemical engineering because I was very interested in how we would apply various chemical principles to engineering problems.
Why did you get interested in NC State?
Well, NC State, as everyone knows, is the best in-state engineering school. It's a state university. So yeah, it was a combination of it being a really good school and being really affordable that made me end up at State.
What kinds of jobs are available for girls out there who want to have a degree in chemical engineering?
Well, chemical engineering is great because it's such a broad degree. You can pretty much work in any industry that you want to, whether it's doing environmental remediation, so like fixing groundwater problems, or you can look at doing foods production or drug production. You can also look at various types of chemical plants, your more traditional petroleum engineers, so you have a really wide range, including even the newest biotechnology type fields.
Tell me a little more about GlaxoSmithKline and about your work there and what you most like about working there.
So GlaxoSmithKline is one of the biggest pharmaceutical manufacturers in the country, and pharmaceutical is a big fancy word for drug. So what we do is we develop new drugs that we then market to combat illnesses. And what I do there is I'm working in pharmaceutical development, so the chemical development group comes up with some new molecule that's called the active ingredient in a drug. We take that and turn it into a tablet that can then be dispensed to patients.
Wow. Did you ever get discouraged in college going into chemical engineering as a female?
Absolutely. The nice thing about chemical engineering is it's actually probably more women than some of the other disciplines. It's probably about 30 or 40% women at State, but I still got discouraged, and I had some professors who were really awesome, like Dr. Hall, who I think is still at NC State, who really encouraged me along the way and told me that I could do this.
And as you might well know, college tuition is going up a lot these days. How did you get money to go to college?
Well, mine was a combination of things. My parents thought it was really important for us to go to college, so they promised half of our education at an in-state school for me and my sister. The other half of the money came from scholarship money that I was able to get by applying while I was still in high school, and also from working in the co-op program, where I actually worked at what it was Glaxo Wellcome at the time, working semesters off between classes.
Wow. So in addition to those co-op programs, what kinds of activities and jobs did you participate in your undergraduate years that kind of led you into chemical engineering?
Well, a couple of the things that I did at State that were really instrumental was that I did a lot of tutoring, which I'd done in high school too. I was really interested in helping people understand math and science better. And then I also one summer did a summer research program at another university, and that gave me a feel for why I wanted to go to grad school and do more research in chemical engineering.
And what was your research at grad school? What did you do your research for your PhD?
So the simplest explanation is that we looked at how particles move through channels. So we were looking at how maybe a cell might be transported through a really tiny channel, like the way it's transported in a blood vessel in the body.
Wow. And what advice would you give to a middle or a high school student who wants to go into the science field and they're females?
The most important thing is to do as much math and science as early on as possible. That made a huge change in how easy, college wasn't easy, but that helped a lot to get through college because I already had my calculus out of the way, I already had some of my basic sciences, and that makes a huge difference. Take all the AP courses you can because it saves you money in the long run.
Wow. Tell us a little bit about GlaxoSmithKline and your work there and what you most like about your work. What kinds of jobs are available with a degree in chemical engineering?
Well, most people seem to think that chemical engineers only do petroleum engineering, so like BP and those companies there, but nowadays chemical engineers do lots more things. We work in pharmaceuticals like I do, in the biotechnology field, so all of these new medical devices and medical advancements that people are doing. Work in foods engineering, so the cereal that you get in the morning, probably a chemical engineer had something to do with that. So it's really a broad range of areas that chemical engineers can work in.
I didn't know what to expect when I was in school.
Well, basically, I thought a chemical engineer was some nerd and 3 floors underground on a computer all day, right? And I'm glad to find out it's not that.
But what I'm actually doing is different than I thought I was going to be doing. I've done, environmental work. I've done mechanical engineering work. I think that there's a lot of opportunity in engineering for different types of careers that I didn't see when I was in college.
At times it can be a thankless job. At times it's a comparatively challenging job. Chemical engineering is just so that I never really diversified, expected how many areas in the world and in industries across the world need chemical engineers. And if you like a certain aspect of science or business or technology, you can fit chemical engineering in there somehow.
I see chemical engineers as kind of the bridge between basic science and a manufacturing process. We take an idea, make it a reality, and make it profitable for the company.
There is the technical side of it, and there's the whole world of other skills that are combined when you actually get into a job. And each job is different. You find that the jobs are much broader than what you think of as a typical engineering job.
I might work on a project in forest products or in energy services or petroleum and chemicals or power.
Any product that you pick up, probably a chemical engineer worked on, from a toothbrush to the chair you're sitting on. So it's incredible what chemical engineers are used for nowadays.
Typically, I'm responsible for managing our area equipment integrity team. I keep our plant on track with our predictive and preventative maintenance on all of our major equipment pieces.
Right now I'm working in product development area, Procter & Gamble, which is basically the research and development group. Specifically, I'm working on hair care technology development, and my current project is to develop a new shampoo formulation.
Right now we're in construction. We have a $1.3 million project where we're upgrading our bulk facility on site. And my job right now, or my project, is to make sure that that's managed correctly. So if I'm not in a meeting, I'm downstairs with the construction workers or with our construction manager and making sure that everything is put in the right place, or it's up to the standards that we hold.
I'm in an R&D program. It's a job where you're actually developing a process or a product.
I work in a central engineering organization, and I really play the role of a technical consultant to all the different areas that make liquids, that have liquids-related problems.
The job I do is more of a general engineering. The units that I'm working with are cartridge-actuated devices. They are units that are used in the air-to-wake escape systems in aircraft. They propel the sequence. Like it starts at when the pilot pushes a button, it goes through a certain sequence till he actually gets out of the plane.
I work in the manufacturing engineering group on inkjet print heads.
I help along with analytical chemists, organic chemists, and pilot plant personnel, drug, pharmaceutical, deliver both pharmaceutical to clinical trials for safety and testing.
My department is the technical support group for the manufacturing facility. I do process development on the cell culture processes that we use to make pharmaceuticals.
And how do you mix it and cool it as you're manufacturing it in the plant? Is it smooth and is it creamy? Does it have those kinds of attributes that the consumer will like to buy? So we also measure those kinds of properties so that we can help people who are formulating the products to really formulate them better.
I work on environmental health and safety assessments and audits, where we go out and we speak to general managers and line managers at each of our manufacturing sites. And
Jif peanut butter, for example, how do you pump it?
Assess the maturity of their environmental health and safety programs.
When a chemical comes into commerce in the United States, whenever it's going to be manufactured, processed, or used in certain quantities, it has to go through a review process, and the engineers in my branch review that chemical for any potential exposure to the workers or people who may be using that chemical during its lifetime.
I worked on production support and improvement, basically solve any kind of bottlenecks that they came across within production, and also to improve the production.
A very large part of the responsibilities of any university professor is conducting research. But particularly professors in the physical sciences, like a chemical engineering professor, they are required to have supported research, submit proposals to acquire their support, and direct the research of graduate students.
We're involved with the equipment that produces all the drugs. We have the scientists who create the process, and they say, we need to do this, that, and the other thing in order to produce this drug. And then they come to engineering, and they let engineering know that we need the equipment to produce, to make this, that, and the other thing. And so that's where we step in, and we design a facility that will have all the utilities that they need.
As a process engineer in this type of a role, one of the main responsibilities of your job is to provide daily support to your unit. And what that would mean is troubleshooting problems that go wrong in the plant, or trying to find ways to run your plant better. Research and development is a place where you're faced with a problem and you have to find a way to answer that problem. So you're constantly looking for answers and ways to apply those answers. We're always searching out and developing new techniques, but we're also doing it in a way that we're going to develop that product for a profit. We're going to sell that product. So it's a real-world application of the engineering field. Superior product.
There is no such thing as a typical day.
Yeah, each day, who knows what's going to happen. And sometimes I'm testing, sometimes I'm writing reports, analyzing data.
I'm product planner on specialty imaging media. If you're developing inks, you're in the lab working with technicians, running tests. What I'm doing now is more of like product coordination for release of new products, dealing with marketing, getting requirements, putting together product objectives and functional specifications. I'm functioning more as a role of coordination of new product releases and getting out the packaging for those new products. As far as I'm not personally designing it, but I review it. I decide what the product's going to look like, obviously with input from marketing and engineering. I work with the design center, graphic artists. I work with printer people to talk with them about what they're expecting, what types of specialty papers and media that they're needing to promote their products, if there's new product applications, what new products we need to be thinking of to go along with those. What I like about it is just the variety of different contacts I have across the site. You get a really wide breadth of exposure to different areas.
In the engineering construction field, our projects tend to range anywhere from between a couple months to a couple years. If you come with me 1 week, you might think it's pretty boring, but over an entire life of project, we get to do a lot of different things. Once we get a job, there's a lot of technical things that we do. Everything from helping the client with his design basis on a certain process. We also do a lot of consulting with the other disciplines. Pretty much process engineers will pick up and start the ball rolling on a project, and we'll develop flow diagrams and material balances and the typical process design type activities. But I want to emphasize that in my experience, I'm not limited to just the technical aspects of my job. I'm involved in sales proposals, I'm involved in the estimating, the scheduling, the budgeting, everything, through even client contacts, vendor contacts. So our technical job is there, but there's so much more than just the technical aspect that we do every single day.
Environmental issues come up all the time. There are always developments in different areas in policy and things like that. Usually it starts out with the pre-manufacturing notification. We'll go ahead and pick up, the submitted data from the manufacturer.